Hi guys, welcome to my YouTube channel. If you are just seeing me for the first time, my name is Bakari Said. I'm a former jupeb student. I'm where you are today, wondering how you're going to solve some hard physics question, hard physics and exercise. But calm down. In today's video, I will be demystifying some tricks because having gone through this jupeb program, I have know where lecturer used to set question. In today's video, I will be demystifying how to solve some question of measurement, quantity, and units. Thank you very much. Let's begin. So, talking about measurements, in the world we are today, we talk about science, and in science, measurement is one of the process in discovery. If an experiment if a scientist want to carry an experiment out, a measurement must be what must be there because, for example, as a doctor, you want to take your patient's blood pressure. So in the instrument that they used to take the blood pressure, there's a quantity, an amount of number that we see in this patient that hey, this patient it has high blood pressure or this patient has low blood pressure. So that's how it is because of this what measurement. So when we talk about measurements, there are two important things you must know about measurement. Number one, measurement has what measured quantities, and also it has units. So when we talk about measured quantities, measured quantity and numerical values like 24, like 90, like 1 and the rest. Why the unit? The unit signify what you are measuring. For example, I want to take the length from that place to this place. So if I want to measure, let me say from that place to that place is 120 inches, right? So that inches that I put, that's what my unit, right? So in a scientific experiment, the value, the measured value or the measured quantity that is used is referred to as what? The physical quantity. So the physical quantity is divided into, it entails into two things. What? The measured quantity and what? And the unit. So this measured quantity can be what? Any number. That's what? Numerical value. Numerical value. Why this unit? E.g. can be anything. It can be centimeter, can be kilograms, can be seconds, etc. So in physics, in physics, we talk about fundamental quantities, we talk about the derived quantity and other quantity. So in today's video, we are going to talk about fundamental quantity first. So fundamental quantities. So when we talk about fundamental quantity, this is a what? This is a basic quantities that other quantities depends on. So This fundamental quantity, from its name, fundamental, is just like a what? A foundation. It's like a foundation for other quantity. So if there's no fundamental quantity, there will not be other quantities. So this fundamental quantity is what? The basic quantity that other quantities depends on. From this fundamental quantity, you can be able to derive other things. So in physics, we have 7 fundamental quantities. We have time, we have mass, and the rest. But I have a mnemonics for you in order to master all the 7 fundamental quantities. So this is the mnemonics. This T term. So if you are able to remember this, definitely you will know how to list what? The 7 fundamental quantities. This on half square, this on half square. Okay, let's begin. This one. Okay. Here is my. Okay. Let's see this. And what? Okay. Starting from this one. Here we have t squared. That means we have 2t. The first t is what? Is time. And the SI unit for time is what? Is seconds. The symbol for time is what? Is t. While the dimension is also what? T. Right? Okay. Let's continue. We have another T. That's what? Temperature. The SI unit for temperature is what? Is what? Kelvin. That's what? Kelvin. Okay, for this one is what? Second. Second symbol. I just say S. Okay, for SI unit, this one is temperature. SI unit is Kelvin. The symbol for temperature is what? Is K. Right? Why the dimension is what? Theta. Okay, let's move to the second one. We have C. This is what? Current. That means current. That's C. Current. The SI unit for current is what? That's ampere. Ampere. Why the symbol for current is what? Why the dimension is I. Okay, moving to the next. We have what? A. The A represents amount of substance. Okay, the SI unit for amount of substance is what? Mole. Okay, the symbol for it is what? Is mole too, in this case, but there's no E here. Why the dimension for what? Amount of substance is what? N. Next one is what? L. Right? The L. First L represents length. So the SI unit for length is what? Meter. The symbol for length is what? N. Why the dimension for length is what? Right? Okay, next one is what? The second L, which represents luminance intensity. The SI unit for luminance intensity is what? Candela. The symbol for this CD CD, why the dimension is what? J. That's what our second N. Why M is what? The mass. So the SI unit for mass is what? Kilogram. The symbol is what? Kg. Why the dimension is what? M. Okay. That's what our what fundamental quantity. We have what? 7 fundamental quantity. Using this mnemonics, you can able to what? To memorize these 7 what fundamental quantity. We have time, which is what? The SI unit is seconds. The symbol is what? S. The dimension is what? T. We have the temperature, that's Kelvin. The symbol is what? A. The dimension is I. The dimension is theta. We have current. The unit, SI unit is what? Ampere. The symbol is what? A. The dimension I, and the rest. These are what? These are what? The fundamental quantities. Now let's move to what? To derived quantity. So that's first. This is second. Derived quantity. So when we talk about derived quantity, we also have derived quantity. This derived quantity, this is a physical quantity that is obtained from combination of 2 or more fundamental quantities. So from the word derived quantity, so this derived quantity is gotten from the combination of 2 or more physical quantities. And remember, this fundamental quantity is also called the base quantity. So we have different examples under this derived quantity. For example, we have velocity. Let's take velocity as an example. E.g., what's velocity? Velocity is what? That's displacement over what? Over time. Right? And all that displacement is what? In our units, where this displacement is also what? Also distance, right? And distance is what? Is meter. Why this time the unit is what? Seconds. So we can say that the unit for this velocity is what? Meter per what? Per seconds. This is what? A derived unit, because it's gotten from what? From fundamental quantity. This is a fundamental quantity. This is also a fundamental quantity. Is a what? Is a derived quantity. So let's do the what? The dimension. So since this is a displacement, it's also distance. If you want to look at the dimension, you have no unit. This is unit. This is what? Meter per seconds. Why the dimension is what? Because this is what? Is meter. We are measuring displacement. The dimension for what? Displacement is what? Length, right? Length. And length is what? L, right? And this seconds is for what? For time. And in dimension for time is what? L raised by what? 1. So this is a what? A dimension of what? Of velocity. Let's take another example. Acceleration. So acceleration, the formula for acceleration is what? Velocity. Velocity over time. So the velocity, we have already known that here is our velocity is what? Meter per what? Seconds. And here, this is our time is what? Also seconds here. Right? So according to law of indices, if you have something like a x times a y, you're resulting, because they have the same base but different power. That means you are going to add up this power. It will be a x plus what? Plus y. But if it is what? Division, if you have something like this, x divided by a y, it will become a x minus what? Minus y. That's what? Based on what? Indices. If you look at this place, it's like this scenario whereby you see division. They have the same base, right? Mind you, there's what? An invisible one here, right? So if you want to do it now, it will be what? S divided by what? S 1, right? So it's become what? S minus 1 minus what? 1. It will now become what? S raised power 2 minus 2. So now our unit will now become square meter per second square. So that's our what? Our unit. That means we have our what? Our unit to be what? Meter per second square. Our dimension to be what? This is what? Meter, right? And a meter is what? It's length, right? This seconds, that's t, and the square, you just put it here. That's what? Our dimension. So let's move on. Let's talk about force. Force. The formula for force is what? Mass times what? Acceleration. And mass is what? The unit for mass. The unit for this force will be what? Mass. And mass is what? Is kg. Why acceleration is this one? That's what? Meter per second square. right? Why the unit, the dimension will be what? This is what mass. The unit is what? Kg. Why the dimension is what? Capital letter M. And this one, this is the dimension here. Just put it here. T raised power minus 2. Let's move on to other quantities. So our first quantity is what? Fundamental quantity. Our second quantity was what? Was derived quantity. So our third quantity is what? Supplementary quantity. Supplementary quantity. So when we talk about supplementary quantity, this supplementary quantity, they are dimensionless quantity. They are used along with the fundamental quantity to what? To form a what? A derived quantity. For example, we have a plane angle, that's radian, right? We have solid angle, that was steradian. Those quantity, they are used along with what? With fundamental quantity to form what? To form derived quantities. So supplementary quantity, these are quantities that are used along with derived quantities. They are used along with what? With fundamental quantities to form derived quantity. And note, this quantity, they are dimensionless quantity, right? That means they didn't have dimension. For example, we have for mass now, the dimension for mass is what? Is m. For time is what? Is t. But this supplementary quantity, they are dimensionless. That means they didn't have what? They didn't have what? A dimension. So example of this supplementary quantity, they are we have what? Plane angle. We have solid angle. This plane angle, the unit, while the symbol Symbol is what? Alright. Why solid angle? We have stone, radian. Why the symbol is what? SR. Right? That's about what? Supplementary quantity. You may ask in your exam, what is what? Another name for this supplementary quantity. Another name for this supplementary quantity is what? It's called pseudo-dimensional quantity. Right? Note. Also note that. Supplementary quantities. Also called pseudo dimensional quantities. Right? From the word pseudo, it means false. Dimensional quantity. That means this quantity, they don't have what? Okay. Moving on to multiple and submultiple of SI units. So this multiple and submultiple of SI units are very important in the fact that they are used when you want to solve physics problem. For example, you are asked to find force. As you know, force is what? Mass, that's what? Acceleration. And your mass, you are given 2 kg. Right? And your acceleration, you can be given that your acceleration is what? Let me say 2 let me use giga. This one, right? And you're asked to find what? The force. How are you going to find it? That means you are going to say force is equal to mass. That's 2 times 2 times, what's giga? You come here. Giga is what? 10 is power 9. That's 9. Right? That means your F will be equal to what? 4 times 10 is power what? 9 meter what? Newton. Or you can say kilogram per what? Meter square. Right? So this is the importance of what? Of these multiple and sub-multiples of what? Of SI units. If you are given in a question and, for example, you don't know what this giga means, that means you are definitely going to lose the mark for that question. So these multiple and sub-multiple of SI units are very important. Starting from this factor, that's 10 raised power what? 24. That's iota. The symbol is what? Y, capital letter Y. This one, 10 raised power 21. Zeta. That's Z. So if you look at this particular place and this particular place, this one is having minus and this one is not having minus. Don't confuse it. So you have to learn it and know what each of them represents. So let's move on to dimensional analysis. on to dimensional analysis. This dimensional analysis, when we are talking about fundamental quantity, we say all those fundamental quantity has their what? Has their what? Dimension. So we have these dimensions are very, very important in physics because they serve many purposes. For example, if you want to derive an equation, you can use this word dimensional analysis. Or if you want to know whether an equation is what is correct or is not correct, you can use this word dimensional analysis to confirm. So this dimensional analysis is based on what? The principle of what? Homogeneity. So this principle of homogeneity states that the dimension on the left hand side must be equal with the dimension on the right hand side. That means if a particular equation is dimensional correct, that means the equation on the left hand side must be what? The same with the what? With the right hand side. So let's talk about what the importance of dimensional analysis and the limitations. Number one. So, like I said before, the importance of this dimensional analysis is what? It can be used to check the correctness of an equation. We all know that in the equation of motion we have V is equal to U plus AT. Right? If you want to confirm whether this equation is what is correct or is not correct, we are going to use what? Dimensional analysis. How are we going to use it? Number one rule is that all numbers, all figures are constants. For example, if we have something in an equation whereby we have 1 over 2, you have pi, all of these are what? Are constants because they are dimensionless. They don't have what? A dimension. Okay, let's continue. These are our velocity. And from velocity, we know that velocity is what? Distance over what? Over time. And distance or displacement is what? L over what? T. So the dimension for what? Velocity is what? L raised to power minus 1. This is the final velocity, this initial velocity, they are still the same. This acceleration, and acceleration is what? Velocity over what? Over time. And velocity is what? Lt raised to power 1 over t. So the dimension for acceleration will be Lt raised to power what? Minus 2. So this velocity, it will be represented here like this: L raised to power 1 equal to Lt raised to power 1 plus acceleration Lt raised to power 2 and our what? Our time T and our time. So now let's analyze. In dimensional analysis, the equation in this side must be equal to what is in this side. So L raised to power 1 equal to L raised to power minus 1 plus, in law of indices, if we have the same base but different power, we are going to what? we are going to add if there's multiplication in between them. So in this place, we are having t raised power minus 2 multiplied by t raised power 1. It will become t raised power what? Minus 1 plus 1, which is equal to what? T raised by what? Okay, since in this equation we are having L T raised power minus 1, and also here L T raised power minus 1, and also here L T raised power minus 1, that means this equation is what? Dimensional correct. That means we are having the same quantity in this side and in this side. Thank you for watching.